Hello, everybody. Thank you very much for attending this webinar. We are from Wellntel. My name is Nick Hayes. I'm one of the co-founders and in charge of technology. I'm joined by Marion Singer, our CEO and my co-founder, and Joe Fillingham, our science lead. And we're going to talk a little bit about a major change in the way we think about measuring a vital resource, and that is groundwater. That is the resource that we share that's under our feet, and how this major change might affect organizations like yours, land trusts, conservancies, orgs that essentially see a reason for stewardship of resources and the communication about their health. It's important to begin with the idea that groundwater is generally the least measured resource. We know where almost all the oil is on the planet, but we certainly don't know where all the groundwater is. And that has implications for everybody that has a stake in groundwater, and arguably we might say that everybody does. But the reason that groundwater is the least measured resource is the technologies and the methods that we've used for the last 50 years or longer to measure them are really limited in terms of scale and effectiveness. We usually measure in just a few locations, a few times a year, and that information doesn't scale well to the places where there are risk or impacts of changes to groundwater. So in this presentation, imagine, if you will, a groundwater information from everywhere, that is data flowing from everywhere and for everyone. And that's what we'd like to talk about as a major shift. Our thinking is that every single stakeholder needs to know about what is happening to the groundwater under their feet. And those stakeholders include really a broad brush of all of society, from counties and municipalities and agencies who depend on facts about groundwater for planning and management, to consultants and scientists and stewards who need to be able to conduct more impactful and extensive studies based on better data, to homeowners and farmers and the outdoor-minded who really need to understand land value and risk and opportunity and potentially the opportunity to conserve if needed, to students and others who might become advocates who need to really develop an awareness of resources, especially those that are shared across society. So if basically all people who depend on groundwater need to know about it, why is it that very few do? Well, the fact is, the upper right-hand corner are two images of technologies that are used currently to understand where groundwater may be at a given moment. And they really, as technologies, they were useful for their designed purpose, but they limit our ability to gather data from enough places and often enough to actually do the kind of good we need to think about groundwater in a more sustainable way. These conventional methods really are designed to touch water, which means they require an open well or a place where you can do that. They require an expert to do the work in order to prevent contamination and evaluate what's happening in the environment. The data that comes from these measurements often lags and is sporadic and is usually contained in spreadsheets on one person's computer and not shared. So we imagined a clean and simple, continuous, permanent, and accurate groundwater information system. That's a heady goal, but the idea was to place smart and simple, novice-friendly sensors in any location where we go get groundwater through groundwater wells. So the image on the bottom corner is a well feeding a vineyard in California. And on top of it is a sensor that is delivering continuous, permanent, and accurate groundwater information over time. Now, let's push the idea a little further than simply a device on a location. If you think about data required for science that might inform, for example, conservation action. Old data about groundwater came in, as we mentioned before, once in a while and from one location. And so we might get a data point in April and July and December. Now, it's nice when we can be more rapid fire about gathering data and collect information continuously, but continuous is really not the way to manage a shared resource. What you must do then is understand relationships, and you can do that when data from many sensors is actually delivered to the cloud. That's where you can visualize patterns and impacts and effects of things like weather and precipitation and climate and population and irrigation. So the next slide actually shows us a little bit about how that might occur for a stakeholder. You're actually looking at actual Wellntel data from, in one case, one well in Wisconsin at a vacation property where pumping impacts are understood by the people who depend on that well. Each one of those events in the time series is a pumping event where water is drawn down in the well, and when the pump turns off, it recovers again. And you can actually see periods when perhaps many people in the property are taking showers all at once at say 10 a.m. or 11 a.m. since it's a vacation home. But more importantly, when you tie data from multiple locations together into into a regional study, what you can start to do with the impacts of the data, or with the relationships between the data, is understand change on a regional scale. And so the bottom charts are contour maps taken from a deployment of 12 Wellntel sensors around a gravel pit where mining is ongoing in Wisconsin. And so the gravel pit is the low spot in this contour map, kind of center left. And that's interesting. What you can see is the drawdown that happens when the gravel pit dewaters, or that is pumps the water out of the pit to make it possible to access more rock. But more important than that, in this case, between October and December, what we're showing is a very healthy recharge of the groundwater table that happened late in the year in Wisconsin. In fact, it was unprecedented. Due to the fact that we had a mild December and no freezing, groundwater was actually able to recharge as it rained, instead of running off the surface because it was not able to penetrate an impermeable ice layer. So this was a very interesting result of gathering data on a regional scale. It showed both human and environmental impacts, and all the people in this network are informed about these changes. Now, this is a brand new idea. If we were to compare the old way of measuring the shared resource that is groundwater against this new concept, this cloud-based consumer grade sensor system, we might consider it in terms of a process comparison. So the old way of gathering data was labor and time intensive, which we've already talked about, and its analysis was mostly done on one person's Excel spreadsheet. And its reach, the impact of that information, was limited in terms of time and space. And a big reason is that all the equipment and the effort around it was too expensive to scale. So the process stops and starts. And that means that when we're in a conversation at a community level about what to do about groundwater management and policy, we end up with a potentially politicized, non-fact-based discussion. So the new way to talk about it, if we think about groundwater measurement from everywhere, involving everybody, then its collection can be automatic and secure. Its analysis can be model friendly for scientists and yet still useful for novices. Its reach can be forever and everywhere, and really become a teachable moment at any moment. The economics change from too expensive to scale to all groundwater now is measurable, since all locations where we depend on it can become monitoring stations. And so the process evolves and grows and builds, and we become more informed about the resource as a society. And that's interesting, because if you think about actions that might be taken, they will be based on facts, and they will already have a collective understanding about where the resource is and why it's a good idea to think about it as either at risk or an opportunity. Now, we have a special program at Wellntel. Yes, we sell sensors to homeowners with domestic wells and farmers with irrigation systems, but we also have a program we call the Sentinel program. Sentinel partners are key, we think, to unlocking key groundwater resource information everywhere. And Sentinel partners are really folks like research universities and NGOs. They are schools like primary and secondary schools and state colleges. They are conservancies and national landmarks and impact investors and other not-for-profits. And they represent a special mix of stakeholder to us. These are people who are especially interested in not just the collection of information, but the dissemination of information. And so, unlike a consumer well, where the data might be essentially held private by the consumer for whatever reason, Sentinel partners agree to share their information with everybody. We're going to talk about 3 examples of Sentinel partners, and I'm going to turn over the conversation to my colleagues here, starting with the Tri-County Network. And I think, Marion or Joe, which one? I forget which one of you is going to take this one.
I'll take that one on, Nick. Thanks very much. This is Joe, the Wellntel Science Lead. The Tri-County Network is a program which is based on the volunteer cooperation of 3 Wisconsin counties, the U.S. Geological Survey and the Wisconsin Geological and Natural History Survey. And the goal of this project was to create a low-cost, low-maintenance, long-term monitoring system to inform and help draw some baselines on the region's groundwater because of impacts from human activities, things like high capacity wells and frac sand mining in the area, as well as the future management, things like permitting new high capacity wells and high capacity well withdrawals, but then also from the ecological and environmental perspective, research perspective, looking at impacts of groundwater use on surface water resources like wetlands and trout streams. And so just this year, Wellntel, in cooperation with these different groups in Wisconsin counties, has deployed 15 Wellntel systems at town halls on private domestic wells, homeowner wells, and as well as agricultural wells. And these systems are online and collecting information, and a lot of important things are being learned here, including having access to information at the stakeholder level. So this information is not just in the hands of one person, but the people that are involved with the study that are hosting these systems have access to that information, and the information is being fed directly to these state and federal agencies for use at a higher level. So this is definitely a cooperative project, and it's having immediate impacts. So the next project, and I think I'm going to hand it over to Marion, is the Kern River Preserve project in California.
Thanks, Joe. So the Kern River Preserve is actually an Audubon Society managed location that is in the east of Bakersfield in California's very important agricultural Central Valley. You can see that on this map that it is actually a riparian forest that essentially a forest of trees that is contingent to a body of water, which in this case happens to be the Kern River. And they were looking to and have been monitoring for a number of years to better understand the interchange and impact between groundwater monitoring and the river itself. The director of this preserve had reached out to us last year with a mission that they'd like to do to take their monitoring to a new level. And here's what he said. He said they currently monitor an array of 12 wells on their property on a monthly basis. They would like to improve their data collection, gave us a little bit of insight into what their system looked like. It was a distance of the wells from to headquarters about 4 to 5 miles. And they'd like to start to understand with a much more granular data set, hopefully the link between human activities and the groundwater and water levels, and then also start to understand how this kind of insight could be used to protect their important environmental assets and develop strategies to collaborate going forward. So you can see that actually this is it's actually a very beautiful piece of property. We installed their first Wellntel in September of last year, and they have just expanded by 3 more Wellntels, and they've got probably one of the highest density monitored networks in California, if not the United States, for continuously monitored wells within a 4 to 5 square mile area. We're looking forward to their report outs as they learn more and start to build this database of understanding. The next example, I'm sorry, Meg, is a school here in Wisconsin, and Nick's going to talk a little bit about it.
Super, thanks, Marion. Badger Rock Middle School is a 7th and 8th grade charter affiliated with the Madison Public School District in Madison, Wisconsin. It is it's a small school that has a curriculum focused on urban gardening and food science and understanding. And so at the school, you can see from the picture of this brand new and beautiful building, the school is surrounded by gardens that the students actually help maintain and manage. In the middle of the school is a fantastic kitchen where they actually prepare their own produce for their own lunches. It's a continuum of education starting from water and soil to calories and healthy and well living. On the site of Badger Rock, actually, let me clarify that in its design, first they wanted to be quite energy efficient, and so this is a high-level LEED building with solar panels on the top, etc. But as it relates to water, this was an area or a plot of land that where the designers set a target to be water neutral. That is, every drop of water that falls on this piece of land stays there in one way or another to support the growing of crops around the school. So there are large water tanks, underground water tanks, and in-building water tanks. We gather rainwater from the roof, and then that water is used again for irrigation. There's also a pumping well on the site, and frankly, it's the first permitted well to the shallow aquifer in Madison's city boundaries in I think 20 years or possibly longer. Wellntel placed a system at the Badger Rock Middle School and essentially handed the keys to the teachers at the school to share the data that comes from the system about rainfall, about pumping, about use during irrigation. And in a new development, Wellntel is about ready to announce, and you are the first to hear of it, a new tank level monitoring system. And so we will be outfitting the storage tanks, the underground storage tanks at the Badger Rock School with sensors as well, so that the students can see the relationship between storage and precipitation and use of groundwater in the complete cycle at the school. The information from Badger Rock is Sentinel information. It's available to other people and neighbors. And they're assisting to expand the network by adding other sites to their map. Now, how does the Sentinel program work? What's special about it, and why is it? Why do we think it's important? Well, if you think about private wells or private homeowners and farmers with wells that are not Sentinel sites, they buy sensors, and they gather data from those sensors, and their information optionally can be contributed to citizen science in the form of regional summaries, but it's not located. That is, it's not possible ever to know exactly what's happening from one Wellntel sensor or another in the area. And the reason for that is that frequently private well owners simply don't want to talk about where the water is in their well. Sentinel programs are different. These use identical technologies and the same cloud infrastructure, but Sentinels agree from the beginning to sign up and become part of a national network of groundwater level observations and sensors, and these data are tagged with location and then made available to academia and education and outreach. And the reason why that location is important is that it enables a much deeper science about the region. It helps people understand where risk actually is happening, where there may be opportunity, and how the system is interacting, either with surface water or with climate change or with population impacts and pressures. So we want to spend just the last few minutes talking about how to participate in a Sentinel program. We're assuming you're in this meeting because you represent potentially a land trust or a land conservancy or an organization interested in natural resources. Well, participation is really kind of three steps. It's commit, and then participate in a deeper way, and then share. And share means, of course, share that information. So the ideas are you would maintain a Wellntel sensor on at least one groundwater well on your land for a minimum of 5 years. You'd provide additional periodic local observations, such as water temperature and water levels. We encourage the collection of additional meteorological and water quality data to contribute to other uses and other correlations in the long run, and we will support that. You would commit to provide information on the state of the well that we are measuring water from, such as depth and screen depth, so that we can calibrate that system appropriately and make sure that it's giving good data. And then, of course, you would agree to share this information and the location of wells freely with the national and regional networks that will depend on it. For all sorts of reasons, education and outreach, and really good use, good management of that resource that's under the land that you care about. How to get started? It's pretty straightforward. If you have wells on land that you manage, tell us where they're located. Maybe send us a Google map or a picture, or describe it, and we'll help you review wells and the locations and pick the appropriate Wellntel system for you and this operation and application. You can start with a few and expand with sponsors. What we mean by that is instead of buying Wellntel outright, you might look to your current donors and members to help with a groundwater monitoring network to build on your site. And we can help you with a campaign like that if you're interested in getting started. Then you can begin to expand your understanding of groundwater, connect to other Sentinels, contribute to local and regional conversations. And to get started, what our initial offer with potential Sentinel partners is that if you buy one system, we'll match it with a second one. So 2 systems can come online. Maybe like Badger Rock, you want to place one on a well and one on a storage tank. Maybe you have 2 wells that are near proximity to each other, and you'd like to measure relationships. Well, we'll pay for the second one and call that a donation to your organization from Wellntel. In a larger sense, we're on the cusp of creating a groundwater information revolution. This has never been done before. We've never really known where it is. We need to know where it is in order to manage it appropriately. We'd like you to join us in the revolution. Thank you. And with that, we'll take questions.